Dmitry Novozeltsev from D-Start LLC presents the Indicator project. Detection of signs of biological activity in the atmospheres of planets and satellites with simultaneous distributed multi-point monitoring of atmospheric parameters in real time based on femto-class probes using technical solutions of D-Start impulse engines. Slide number 2. Today, the mass of spacecraft in the minimum configuration, the so-called femto-class, is units or tens of grams, and the dimensions are tens of millimeters. Examples of such probes are, for example, the IS-1 satellites. Each probe is capable of transmitting its exact coordinates, as well as the readings of one of the senses: temperature, pressure, humidity, chemical composition of the medium, UV radiation, and so on. In addition to the actual space launches, such probes are widely used in educational and research activities (INCL). For launching on balloons. On satellite IS-1, acquired by D-Start LLC for flight tests of the engine, a sensor is installed to register the temperature, pressure and chemical composition of the working fluid. Slide number 3. The possibility of using such probes in the atmosphere of Venus has already been considered, for example, as a group of free-falling probes launched from a common container. They developed to make a short flight in the atmosphere due to the aerodynamic lifting force of a thin plate, and during the flight, transmit data about the environment. Slide number 4. D-Start LLC is developing a family of impulse engines for such femto-class probes. With the use of the constructive groundwork, it is also possible to create similar small balloons. In this case, instead of an open reflector, a balloon envelope is used, in which, instead of the engine target, a charge of the gasified material is located to deploy the envelope and inflate it with a heated gas. Both designs also include a suspension for attaching the payload, the femto probe, to the shell. It is proposed to use such balloons with a ribbon suspension for the indicator experiment. Slide number 5. Earlier, the use of such a suspension in the form of a tape was planned on the IS-1 satellite for flight tests of the Impulse 0 engine. Bench tests confirm the sufficient strength and reliability of such a suspension and its resistance to damage. Slide number 6. The Indicator project assumes the use of a group of similar small balloons, identical to all motions, except for the suspension design. The suspension has the same tensile strength under operating conditions, but the entire suspension or the small indicator insert is made of different materials. All materials have comparable mechanical, thermal and chemical resistance to environmental conditions. But at the same time, the indicator materials of the suspension are conditionally biodegradable for the expected hypothetical forms of metabolism, for example, in the case of clouds in the Venusian atmosphere. For metabolism with the release of phosphine, the active development of hypothetical microorganisms on this material, as on a nutrient medium, should lead to its destruction. Slide number 7. The Indicator experiment involves the launch into the atmosphere of a large experimental group of small balloons with femtoprobes, each with a mass of tens of grams, of the design described above. With various indicator materials, from a common carrier, a large balloon, an orbiting spacecraft or a landing probe during landing. A control group of the same suspensions with identical weights is observed in an artificial environment simulating the conditions and chemical composition of the studied atmosphere. Normally, all suspensions in the control group retain their strength until the end of the experiment. The balloons of the experimental group carry out a long drift in the atmosphere at a given altitude. At the same time, femtoprobes carry out a distributed multi-point monitoring of the main parameters of the atmosphere in real time and transmit data to an orbiting spacecraft. In any case, these results are of significant scientific value, also because the distribution of hypothetical microflora in the atmosphere may be uneven and depend on conditions. Chemical composition sensors, in particular, can record the distribution and concentration of phosphine in the clouds of Venus as a possible biomarker. In this case, the failure of balloons due to the breakage of the suspension can also be recorded. At the same time, when the femtoprobes fall in the atmosphere, a characteristic change in parameters is recorded, which makes it possible to distinguish the suspension of the suspension from other damage. For example, a rupture of the shell, in which the fall will be slower. Break of the experimental suspension with the safety of its analog in the control group, especially repeated one, will not only allow us to assume the biodegradation of the indicator material, but also to assess the probable nature of the metabolism of the hypothetical atmospheric microflora, and to choose the optimal nutrient medium for its subsequent detailed studies. Slide number 8. At present, there is a scientific and technical groundwork for dropped atmospheric probes with a low mass, up to 100 grams, and for balloons deployed in the atmosphere. This will allow the development and preparation of the indicator experiment for its implementation within the framework of the Venera-D program. Slide number 9. Similar indicator experiments are possible in the atmospheres of other planets and satellites, for example, Mars or Titan, using appropriate indicator materials. At present, we ask you to consider the proposal of D-Start LLC on the preparation of the indicator experiment within the framework of the Venera-D program. It is also necessary to decide on carrying out work on the selection of appropriate indicator materials.